Use the table on the following page to complete questions 1 through 5. The information in the total column will be used for all calculations in these problems. So this is the total column, the one that is starred here in orange. So these are the numbers we are going to use. And I will not be referencing back and forth, so you might want to take a picture of those numbers or write them down, or just trust me, I guess, is always another option. But those are the numbers we're going to be using for all these problems. So let's jump in to number 1, letter A. What is the total population for under 15 years old? We call these the children. So there are 3 groups that are under 15. So we have 21,265 plus 20,870 plus 20,020 for a total of 62,155. So that's how many total children we have. Now, when we go to 1B, which is the 15 to 64-year-old, there are a lot of them, and I'm not going to write them all out. But when I total them up, I get 204,775. And then for the old population, 65-year-olds and older, again, we just have a couple. We have 12,160 plus 9,254 plus 7,088 plus 5,719 plus 4,957. Man, there are more than I thought. When we add them all together, we get 39,178. So these are the totals we're going to need as we move through this problem. Number 2, what is the ratio of under 15-year-olds to the total population? So we're starting with under 15-year-olds, and we know, based off of that last one we just did, 1A, under 15-year-olds is 62,155. Now it says 2 represents our division bar here, and then the total population. Well, we didn't find our total population. We found each chunk. So if I add my children, my working class, right, the 15 to 64, and then my 65 and over, I get a total of 306,108. So my total would be 306,108. So there's my ratio as a fraction, but notice that the directions say round to the nearest thousandths. So I'm first going to change it to a decimal, and that would be 0.2030. Thousandths is the third place, so I look at the 0, 0 rounds down, so I just have 0.203. And 2b, what kind of ratio is this? This is part to whole, because our denominator is talking about the total, and the total is whole. Moving on to 2c, this means there are how many people under 15 for every 1,000 people? Well, our decimal approximation was 0.203. If you remember, 3 decimal places, we have tenths, hundredths, thousandths. So these 3 spots represent thousands. If I would turn this into a fraction, it would be 203 over 1,000, which translates nicely into this answer for 2C, which is simply 203. So there are 203 people under 15, the age of 15, for every 1,000 people in our population. Now, when we work to letter D, we can use this same concept and think, if we know that it's 203 for every 1,000, how many would it be for 100,000? You can either solve this like a proportion, or you can say, what did I multiply by 1,000 to get 100,000? Well, here's 3 zeros, here's 3 zeros. Notice I have 2 extras. So I need to multiply by 100 to give me those 2 extra zeros. So if I multiply the top by 100, I'll have 20,300. So for every 100,000 people, there are 20,300 of them under the age of 15. So it's all in proportion depending on how many people we have. All right, let's move to our next age group, 15 to 64-year-olds. Ratio of this group to the total. So we have 204,775 working class, 15 to 64, to our total of 306,108. And again, we're going to change it to a decimal, so that decimal is 0.6689 when you divide. And we went around to the nearest thousandths, third place. If I look one past, that 9 rounds up, so I am left with 0.669. as a decimal. And again, this is a part to whole ratio because the denominator is the entire population while the numerator is part of the population. We're going to use that decimal of 0.669 to lead us into letter 3C. Again, if we have 0.669, we could write this as a fraction of 669 over 1,000, which means for every 1,000 people, 669 of them are between the ages of 15 and 64. When we go to letter D, same concept. If I multiply 1,000 by 100, that gives me 100,000. So if I multiply 669 by 100, that gives me 66,900. So for every 100,000 people, there are 66,900 of them between the ages of 15 and 64. You can see that is our largest population, so that does make sense. And let's go to our letter 4A, which is the oldies, as I call them, 65 years old and older. So we have 39,178 oldies compared to our total population of 306,108. If we change that to a decimal, we have 0.1279. Again, to the thousandths, that's the third place past the decimal. I look at the 9 rounds up, and I have 0.128 as my decimal, the ratio of oldies to the total population. And again, just like the last two, this is a part to whole ratio because there is part on the top and the whole, the entire population, is in the denominator. Okay, so again, we're going to use our decimal to lead us into 4C. If we have 0.128 and I change that to a fraction, 3 decimals means thousandths, so there are 128 people aged 65 or older for every 1,000 people. And if you think about it, we had 203 young ones, 669 oldies, and 669 workers, 128 oldies. If you add those together, that gives you your 1,000 population. So these these decimals, these ratios, lead us to the direct proportion of people that we need. Okay, let me get rid of that because it's not anything to do with this problem. And then going to 4D, if we multiply our denominator by 100, right, because again, we want to get 100,000 in the denominator, so I would end up with 12,800 in the top. So for every 100,000 people, there are 12,800 people aged 65 and over. And the last question, number 5, what percent of the total population would be classified as child dependent? Meaning, what percent of the total population are children? So if you go back to letter 2A, which is where we saw our ratio of children to the total is 0.203. Well, because it's part to whole, remember that if you are part to whole, you can write it as a percent. Because, pie graph, just thinking about it, pie graph is a full percentage. So if 20.3% are children, right, we can break it up that way. How many would be workers? And how many would be oldies? This pie graph is not to scale, but the pie graph has to add up to 100%. So part to whole, this is why it works, because the whole is the entire pie. So I want to change this percent or this decimal to a percent, and to do that we multiply by 100, which is the same as moving your decimal 2 places. So our answer is 20.3% of our population is child dependent, right? They are children. In 5B, what about workers? Well, our workers were 0.669. So I multiply by 100, right, which is the same as 2 decimal places, and I'm at 66.9%. In my oldies but goodies, we're at 0.128. If I multiply that by 100, which is the same as 2 decimal places to the right, I'm at 12.8%.